and welcome to 65th episode of PEEPanEIP, an educational video series where we discuss an Ethereum improvement proposal, upcoming upgrades, and the basics of Ethereum blockchain. I'm Pooja Ranjan, and today we are going to discuss EIP-4337 account abstraction via entry point contract specification with two of the co-authors of the proposal, Yoav, Kristof, and some of the proposal implementation team members. Kristof is with one of the popular execution client, Nethermind, and Yoav is a dev with Ethereum Foundation. A quick intro to the proposal. EIP-4337 is a standard track ERC, which was initially proposed in September 2021 by Vitalik Buterin and team. The EIP proposes an alternate method of account abstraction. We will learn more on the topic in a while. First, let's meet our guests for the day, Kristof and Yoav. Welcome to the show.
Welcome.
Thank you.
Well, welcome to me and to us, I guess. Yeah.
Right. So generally, we start with a quick introduction of the guest, and our viewers love to hear your background and how you joined Ethereum community. So whoever wants to go first.
Right. So I'll start. So my name is Yoav. I'm a hacker and a researcher at the Ethereum Foundation, and I've been working on decentralized infrastructure for a few years now, along with the OpenGSN team. Some of them are here. We've been building the gas station network, and in the past few months, we've been working on this new account abstraction proposal, which is based on something that Vitalik suggested, and we had some interesting discussions about that. So what we're presenting today is the result of this work. Right. So
Sure. And I'm Kristof. I joined Nethermind last May through their internship program. Since then, I've worked on research and implementation related to MEV, the merge, and now account abstraction. And there I'm a product manager and researcher for the most part.
Nice, thank you. I know there are some other members of the team. If anyone would like to give a quick intro.
So if nobody wants to speak, I guess we can get started.
That's all right, yeah. And moving on, yeah, I suppose you guys have a presentation to share. So without further delay, let's just peep in.
All right, yeah. Can you guys see the presentation?
Yes.
Cool. So we're here to present EIP-4337, which is an account abstraction proposal via alternative mempool. So we've already had our introductions. So it's me and Yoav presenting. First of all, it's good to note what actually is account abstraction. So account abstraction is a goal in Ethereum to move away from EOA accounts, right? Accounts controlled by private keys, and move and incentivize smart contract wallet adoption. Specifically, what we're trying to do is we're trying to allow smart contracts to initiate transactions. The way it works in Ethereum right now is that all transactions must be originated by an externally owned account, and this gives rise to several problems in Ethereum, like the fact that these external accounts always have to have ETH in their wallet, that controlled by one specific signature scheme, ECDSA, and many others, which we'll cover throughout the proposal. So how does this proposal work? ERC-4337 introduces the concept of user operations. These are structs, like you can see here on the right, and they have 12 fields. They specify everything from where it should be routed to, the signature that's used, if there's a Paymaster, and lots of other custom fields. And the way it works is that users will state, they'll state their intention with these user operations, sign them, and they'll send them into a separate mempool distinct from the normal transaction pool. And these user operations will then be propagated using P2P, just like normal transactions are. Now, but here bundlers come along. These can be anyone, although the best candidates for bundlers are miners or MEV searchers. These bundlers take these operations and place them on chain and send them on chain via a specialized contract called the entry point. And this entry point is going to make sure that the bundler gets paid for including the user operations on chain, and then execute any arbitrary call data as specified by the user. One of the best parts of this proposal is that it's completely compatible with the current Ethereum protocol. We're building a system that is in a way above the current transaction pool mechanism that we see in Ethereum today. And no special transaction types or any other rules are required to be changed in the current Ethereum implementation. Right, and here's a nice diagram made by Vitalik, which kind of portrays how this proposal works. Right, so there's users, they create their user operations, they send them to nodes, and these get picked up by bundlers. And these bundlers are gonna take these user operations and bundle them into one big transaction through the entry point and include them as any other normal transaction in an Ethereum block. All right, so what are the use cases and why should we make this a standard? We need account abstraction now. There have already been proposed many EIPs which aim to achieve account abstraction, such as 2938 and one previously, I think it was 86, correct me if I'm wrong. But any change, any consensus change, especially with regards to account abstraction, would take many years to actually succeed to be part of the Ethereum protocol. All the devs right now are working on the merge and other EIPs, and we think account abstraction is so important that if we can solve it with an ERC, then we definitely should. Account abstraction and the ERC incentivizes smart contract wallet adoption. The next financial system should not rely on people storing their life savings on 12 words on a piece of paper, as currently required by externally owned accounts, right? And anything which gets us closer to a state where people are using multisigs and social recovery more often is really beneficial. And so we believe that the UX gains from this ERC would incentivize people more to start adopting smart contract wallets. So there are smart contract wallets currently available, which already do their own version of account abstraction. However, this means that they need to run their own relayer networks. Instead of spending all that extra energy and having a separate relayer network for each use case, it'd be very beneficial to have a universal and widespread interface for account abstraction that any of these solutions can just plug into. Currently, all Ethereum transactions will be signed by ECDSA, which is an elliptic curve signature scheme. But this EIP allows for any custom signature scheme to be used for validating whether user operation is valid or not, right? Anything that you can write in a smart contract can be used as a signature scheme. So this would allow us to use more efficient signature mechanisms like BLS, for example, or even quantum resistant ones already like Lamport or Winternitz. So we could, using this proposal, already make Ethereum quantum resistant. If a user wants to upgrade their wallet, they can use an upgradable proxy mechanism, and this is completely compatible with this EIP as well. A really cool feature of this EIP also is that it allows for the use of what are called paymasters. These are separate smart contracts which are allowed to sponsor transactions on behalf of users. So this the case with Paymasters, it allows for paying with tokens, right? You do not need to have ETH stored in your account to transact. You can, yeah, as mentioned before, you can trade without native currency. So for example, you can use Uniswap. If they're willing to sponsor your transaction, you can use any other DApp if they're willing to sponsor users' operations. ZK mixers rely on people withdrawing their funds through a relayer network right now, which is another instance of just lots of extra work for not much benefit, while they could plug into a separate interface like the one we're creating. And if users don't want to use the relayer network, if they don't want to trust it, they have to take it out using an EOA transaction, which again would mean that they would lose the privacy that they would gain from the mixer. And Paymasters also allow for even completely separate use cases, like paying off chain with a credit card. Credit card provider could give the user a signature if they successfully pay, and they could use this for sort of authentication, and it would allow them to get funds from the Paymaster. Multi-operations as well. So the classic problem with ERCs is that you have to call approve and transfer from in separate transactions. This is a major UX hurdle. And since all transactions will be made from a smart contract, these could be batched up into a single user operation. I mean, it's decentralized as well. So all of the propagation happens using P2P, and there is not any single trusted entity that's required for this to work. Incentivize, right? So bundlers get compensated for including user operations on chain, and in fact, they even make a profit doing this. So, for example, by allowing MEV searchers to bundle user operations, we can make sure that all entities involved in making this EIP happen are incentivized monetarily to do so. Since this is an ERC and not an EIP, it's possible to do a slow rollout, right? So we don't require immediate adoption by all miners to make this happen. It's possible even on mainnet, for example, to have 0 miner adoption at the start, and this proposal could still work because we could initially rely on MEV searchers to do most of the user operation inclusion on chain. But in the future, it is very beneficial for miners to be the ones to be doing bundling, because they're the ones who can make sure 100%, except for if reorg happens, that user operation that they include will not result in them losing money. Finally, future-proof. So Ethereum, we think, is moving and should move in the future to a state where EOAs are phased out completely. And this is a really good stepping stone. This EIP is a really good stepping stone for that, because eventually it will be possible to, for example, replace all EOAs with a default smart contract. And that smart contract in the future could be compatible with this ERC. However, there are a few drawbacks that are important to mention, right? Since validating a user operation relies on looking at EVM state and executing EVM code, there's a higher potential DOS vector because of it. The way it's currently designed, only one user operation per sender can stay in the mempool, in the user operation pool. This means that users, if they wanted to send multiple user operations, would have to wait and send them once the first one's included. And finally, there is a gas overhead. There is a total of 54,000 gas overhead for user operation, as opposed to just sending what you'd like to do directly from an EOA. However, 28,000 of this is shared. So, for example, if a bundler was including 10 user operations, then this 28,000 shared gas that has to be paid would be split among all the 10 user operations.
All right, so I'm going to go through these diagrams showing what happens with the user operation once it's submitted by a bundler. So initially we'll go through the simple flow where there is no paymaster and the wallet is paying for the user operation itself. So the bundler creates a bundle containing one or more user operation, and this is sent to the entry point contract. The entry point contract is a singleton. There is one on the entire chain. And this is what the bundlers use. So the bundler sends the bundle to the entry point, and the entry point runs two loops. In the first loop, it runs the validation for all of the user operations. They all run consecutively before any execution, so that validations don't have cross effects between them. So what happens first in the first loop is the entry point calls the wallet's validation function, which each wallet must have before. So the wallet validation gets called, and in this validation function, the wallet checks the signature, and it can check any type of signature. So it could be ECDSA or BLS or some future quantum resistant or a multisig scheme or anything. So the wallet verifies the signature, and it also handles the replay protection, which can be incrementing a nonce. So the nonce is actually part of the wallet storage now. It can increment a nonce, so it can use different replay protection schemes. And finally, it pays for it if it validates the transaction, the operation, and it thinks that it's okay, then it pays the entry point for the maximum cost of the transaction. This is similar to the way EOAs work, where initially the maximum cost of the transaction is charged and then refunded. So at this point, the wallet pays the maximum amount and returns. And now if the wallet returned okay and didn't revert at this point, then entry point proceeds. It does this for all the wallets. After it's done, we get to the execution stage. At this stage, this is the second loop. In this loop, the wallet's operation is actually executed. So it calls the wallet with the call data from the user operation struct. And this can, for example, call an execute function in the wallet, where the wallet will perform certain internal operations, or it will act as a proxy and perform operations on any contract on the chain. And after each operation, entry point also refunds the unused gas, just like with an EOA. So that's how. So that's the flow for a simple wallet transaction. And now let's look at the Paymaster case. So this is so let's say we have a user operation where Paymaster is set, is non-zero. In this case, entry point looks at the user operation, and it sees that there's a Paymaster. So it still calls the wallet validation. The wallet validation, but it tells the wallet validation that it needs to pay 0 for the gas. So the gas payment will come from elsewhere. The wallet still performs the signature verification and the nonce increment or whatever replay protection it implements, but it doesn't pay. It just returns okay. Then the entry point checks if the Paymaster is valid, which means that it needs to be staked. And I'm going to elaborate on why this stake is needed and how it is used later in the security consideration. But for now, it suffices to say that entry point checks if this is a known and a staked paymaster. Then it calls the paymaster's validation function, so the paymaster also gets to look at the user operation and decide whether it's willing to pay for it. And if it sees that it's something it is willing to pay for, then it will return okay, otherwise it will revert. In this validation function, it's supposed to check things such as it can be a white list of certain users, or it can be maybe if it's a token paymaster, maybe it can check whether the user has sufficient balance so that the paymaster will be able to charge for the cost of the transaction. So after this validation, if it returned okay, then entry point proceeds to execute the operation and just measures the gas. Now the wallet operation is performed just like in the previous case. And after the execution completes, the entry point calculates the actual cost of the transaction and deducts it from the deposit of that paymaster. Each paymaster has a deposit. So the cost of the transaction is deducted. And finally, if the paymaster requested a post-op call, then a post-op function in the paymaster gets called, telling it, giving it the context it created and telling it how much it was charged for this operation. And this is used for internal bookkeeping or for charging the user. So, for example, if it's a token paymaster, then at this point it's going to charge the user, because now it knows exactly how much it paid for how much ETH it paid for the gas, so it can calculate an amount and charge the user somehow. And that's it. That's how the operation works in case of a paymaster. Yeah, thank you. So in order to provide all of these services, the entry point singleton contract needs to implement some interfaces for serving the three entities involved. The first entity is a bundler. And as we said, the bundler can be a miner or block proposer, but it could also be an independent bundler. And the bundler prepares the bundle. During bundling, it first uses a simulation function, which is called off-chain. This is a view function called the simulate validation. It receives a single user operation, and it checks it against the current state to make sure that it is safe for inclusion. And this can be done per op, because since all those operations are checked before any execution, they have no way to affect each other. Therefore, it's okay to simulate each of them and add it to the bundle. And then afterwards, it estimates the gas. It uses estimate gas to check the entire bundle to see how much gas it should add, and it sends it on chain to the handle ops. The handle ops interface runs the two loops that I described before and actually performs the work. So this is what the bundler uses. Another entity that uses the entry point is the paymaster. So the paymaster needs to maintain a stake, which again I'll elaborate on later, which means that we need to have functions for managing the stake. This means adding being able to add a stake and say what the unstake delay is. And then there's the unlock stake for unlocking the stake. And once the paymaster unlocks the stake, it stops being a valid paymaster. And then after the delay, it can call withdraw stake in order to withdraw the stake. And the third thing is the deposit. So both wallets and paymasters can have a deposit. Paymaster must have a deposit. And And the deposit is where entry point actually charges the gas. So a paymaster must have a sufficient deposit, and after it accepts the payment and the operation is done, this deposit is charged. And wallet can have a deposit or can pay directly, but there is some gas saving if the wallet tops up this deposit, because it saves the need for transfers inside the user operation. So in order to manage the deposit, we have a balance off. To check the balance. We have a depositor which adds funds to the deposit, and we have a withdrawal. And of course, the deposit, unlike the stake, is not locked. It can be withdrawn at any time. And now wallets and paymasters can do pretty much whatever they want, but they need to implement certain interfaces. The wallet only needs one interface. It needs a validate user op. This is the validation function, which is called during the first loop. And this function should look at the user operation, verify the signature using whatever signature scheme it uses, which in our current sample just uses recover for ECDSA. And it should also handle the nonce, okay, increment the nonce in the simple case. And finally, it needs to pay the missing wallet funds. So missing wallet funds is what entry point calculates to be the missing funds for the maximum cost. If the wallet already has sufficient balance in the deposit, then this number will be 0. Also, if there is a paymaster, this number will always be 0 if the user operation has a paymaster. Otherwise, this number will reflect the funds missing from the deposit in order to accept the user operation. And afterwards, there are no more interfaces for the wallet, because we're just going to call it with the call date of the user operation. The paymaster needs to implement, it must implement a validation function. This is the validate paymaster user op. This validation function is this is a view function because it doesn't actually need to pay. It must have a deposit anyway. So it only checks the user operation to see if it should pay for it, and it can optionally have a post op in case it wants to perform any bookkeeping or charge the user at the end of the operation. So if the validation function returns a non-empty context, then post op will be called. Otherwise, it doesn't need to implement it. So probably the most important thing in this proposal is the security considerations. And we have some security considerations around the smart contract and others around the mempool. So let's start with the smart contract. The entry point is trusted by everyone. It is trusted by bundlers to properly compensate them for the bundle. It is trusted by the wallets, most importantly, because the wallet fully trusts it to execute operations on behalf of the wallet's owner. So so it is critical for the wallet that entry point will enforce certain invariants. And it's also trusted by the paymasters because they need to know that they will be charged fairly and not griefed by the entry point. So entry point enforces a lot of invariants. I'm not going to go through the entire list here, but we can go back to it if questions require it. The other security considerations are DOS or denial of service attacks against the nodes and the bundlers. And as Kristof mentioned, there is increased exposure to denial of service. This is because the EVM, because we require a EVM state, we require actual EVM execution in order to determine the user operation validity. And this allows a certain DOS vector. What happens if what happens if an attacker creates a very large number of valid user operations, which are valid at the time when they are submitted to into the mempool. But then with a single state change, or even with no change at all, by looking at something like the block number or the block time, it could invalidate all of the ops at once. And in this case, the bundlers will have to resimulate each of the ops in order to drop them. And this is a lot of unpaid work. It could even stall the bundler for a long time, making it miss a block. So this would be unacceptable, of course. And this is made worse if there's a malicious or buggy paymaster, because there can be a large number of user operations that depend on a single paymaster. So we have many mitigations against it. We can start in the next slides. We'll see them one by one. The first line of defense is the validation gas. The validation represents a risk of unpaid work for the bundler, and it also creates a load on all the nodes in the mempool, because they may be simulating the entire operation, the entire validation, see that the validation fails and have to drop the operation, which means that it will go unpaid. So this needs to be kept to a minimum. Therefore, validation gas must be declared by the user in the user operation, and it has to be kept low. If a certain wallet or certain paymaster requires a very high gas price for validation, then it's likely that bundlers won't accept this user operation. It can still be used with a private bundler, or even by the user submitting a bundle directly as a transaction, but the bundlers and the mempool will not serve it. And finally, entry point will enforce this gas limit. So if the validation actually requires more than that, then this op will fail. And therefore it will not be valid for the mempool. Another thing we need to consider is environment consistency. We need to make sure that the only thing that can invalidate an op is a change in the state of the wallet. It shouldn't be affected by the environment, because, for example, if the validation function would be allowed to look at the block number, or the time, or even something like a gas price, then it could become inconsistent. So it will succeed during simulation, and then later fail when it is bundled. So we had to ban all of the environment opcodes, and so all of the ones listed here are banned. There is one special case of create2. Create2 is also used for creating the wallet if it doesn't exist yet. But in this case, the user has to specify an init code for the wallet. So if the user operation has an init code, a non-empty init code, then we do allow exactly one create2, which will happen from the entry point itself. And we also verify, as part of validation, we verify that the created account ends up being the sender of the user operation. Any other use of create2 is restricted. And another thing we needed to take care of is code consistency. If the executed code can change in any way, then it could also invalidate a large number of user operations. So when first admitting user operation to the mempool, when nodes check if it's valid, the bundler also calculates the hash of any account accessed during validation. And this includes accounts that are called or accounts that are it looks at their code hash or any other way of accessing the account. And then during bundling, when it needs to check validity again, it checks all of these hashes before simulating. If any of these hashes changed, then the user operation is dropped without simulation. And this leaves us with the storage access. So we need to make sure that a single state change shouldn't be able to invalidate a large number of user operations. It should only invalidate a single one. So we do it by enforcing that the wallet validation function is only allowed to access the wallet storage. It cannot access the storage of any other account. And so we enforce that, and this is complemented by a rule that says only one user operation per wallet can be in the mempool at the same time. So with this limitation combined with the storage limitation, it means that the damage of the amount of work caused by a single state change is limited to one op. And this limitation may be a UX problem, because the user might want to send more than one operation, but this can be solved by batching. The wallet can implement its own internal batching, so you can send a user operation that actually wraps multiple operations, and you can also replace the existing one by fee, just like a replace by fee for current transactions. Paymaster validation also has a similar restriction, where the Paymaster should only access its own storage, but this is not sufficient, because unlike wallets that can only have one op, a Paymaster can have a large number of ops that it affects. Therefore, we needed a reputation system where we can throttle and ban Paymasters that cause too much unpaid work. And this is where the stake comes in. We needed, first of all, to create a Sybil resistance mechanism. So Paymasters must lock a stake, and they have an unstake delay. If a Paymaster, and in order for a Paymaster to be valid, it must lock some ETH, and this ETH has to remain locked. Once it gets unlocked, this Paymaster is no longer considered valid, and any op specifying it will be dropped. Now, can you go back, please? Thank you. So this is the Sybil resistance. But so this is Sybil resistance, and now that we have Sybil resistance, we can have reputation. So we calculate it by calculating an exponential moving average that tracks the Paymaster inclusion rate. This means that we divide the number of ops included by the number of the ops that were seen. So this is the inclusion. This reflects the inclusion rate, and this rate must be kept sufficiently high. If it drops below a certain point, it means that the Paymaster is causing too much unpaid work, so it will get throttled. And eventually, if it keeps doing that, it will get banned. Now, this is a temporary situation, because this is a temporary situation due to the moving average. But if the Paymaster keeps misbehaving, then every time it gets unbanned, it will get banned again quickly. So it can't cause too much work. If an attacker tries to do something, bad, then the attacker needs to either deploy a lot of Paymasters and lock a very large amount of ETH in order to have a lot of Paymasters running at the same time, and each of them causing a very minimal amount of work, or it has to keep removing and recreating Paymasters in a new address which means that the unstaked delay makes the attack very ineffective. It causes a very small amount of work and then has to wait for a long time. All right, let's move on.
All right, let's talk about the bundler implementation. So as mentioned before, anyone can become a bundler in this proposal. The ERC doesn't restrict who are the possible bundlers that can batch and submit user operations on chain. However, we believe that one of the most effective bundler candidates are the miners themselves. So at Nethermind, we've implemented all of this logic that we have described previously. It's part of the Nethermind client now. It contains logic for the mempool, for a separate mempool, for the P2P propagation. We have come up with a separate P2P specification specifically for user operations. It also does batching, and it's currently running live on Gurley already. So after this presentation, we'll send you a link that I guess you can include for the viewers, where we already made a guide on how it's possible to submit a user operation to our Gurley bundler. We also have a working implementation with the GEF client, specifically MEV GEF for now, but we're also gonna port it to normal vanilla GEF. As mentioned before, a cool part of the proposal is that since anyone can be a bundler, we don't need complete miner support initially. We don't even need any to begin with, because if the user operations are profitable enough, we can very reasonably expect that MEV searchers are going to be prime candidates to include user operations as well. So it's very feasible to have an MEV searcher script which just subscribes, which just runs a node, another Nethermind or a GEF node that we've forked, and just subscribes to new user operations entering the pool. Takes these user operations, checks if they're profitable enough. The node will have already checked whether they succeed or not. So that's no need to check that again. And after they do, they just submit it on chain as fast as they can, hopefully competing with other MEV searchers to do the same thing. And since MEV searchers are very competitive, and we can expect that this will result in very high rates of user operation inclusion, even in the very beginning. So here are a few links that might be interesting. We have the proposal itself. Vitalik wrote a blog post a few months ago detailing how this proposal works as well. We have a Discord channel that, if you're interested in the proposal, we'd love for you to join. And finally, the link for the contracts as well, the smart contracts. So do you have any questions?
Well, this was a great presentation. Thank you so much for sharing in detail. It also explained on the bundlers and the wallet, and it definitely helps. I believe there is one question. Yeah, William Sharp, I see there is a comment. Please go ahead with your question.
Sure. So yeah, amazing presentation. There was one thing I did want to ask, which is actually kind of meta about the EIP itself, which is this is an ERC, it seems, because I mean, you've focused on the contract quite a bit here, but is there also going to be an EIP about the network? Because I mean, a lot of this also seems contingent on the kind of libp2p network that's being specified here. So is there a specification for that? Is it going to be a separate EIP? Like, where does that fit into everything?
Okay, so we have just recently settled on the P2P specification. And we're planning, I think you agree, like we're planning to include the P2P specification as well in the same EIP. So yeah, does that answer your question?
Yeah, I think it does. I mean, I guess this is an interesting kind of EIP1 question, which is like, if you have one EIP which is specifying something with just both contract standard, like an app layer standard and a networking standard. So then like where does it go? But I mean, I guess that's something for the squad of EIP editors to decide on. So, okay, I did want to add, like, I maybe try and nudge a bit also about the P2P specification. If you're saying that that's something that was only recently decided on also, so maybe I'll just save that as a coming attraction for when it gets added into the EIP.
Sure, it's usually decided, like settled on, but we have had one running for quite some time already. It's just we have made a few improvements here and there. Yeah.
Mm-hmm.
I still have some other questions for you, although you already have answered a lot of questions in your presentation already. We know that there are a couple of other EIPs in the EIP repo for account abstraction. EIP-86, that was abstraction of transaction origin and signature. And there's another one, EIP-4337, account abstraction. Yeah, but for some reason, they both ended up as stagnant. So it is interesting to learn what EIP-4337 has to offer. I am more curious towards the type of the proposal. It is an ERC instead of EIP because they do not propose any consensus change. What do you think are the advantages for this proposal that may help it to move towards a standard?
Yes, so the difference is when looking at proposals like EIP 2938, for example, it serves a very similar purpose and it could solve the same use cases. But as we all know, it's really hard. I mean, making such a big change as an EIP is something that takes a long time and very hard to get it through. And we thought that it may be beneficial, first of all, to have something earlier, and also it allows us to start the experimenting. So it's something that we can deploy right away. We can start, and people can start experimenting with the model. And now the end game, eventually we will want account abstraction to happen at the protocol level. So in the future, there will, in the future, if we get adoption for this proposal, we should have another an EIP for a consensus change in which maybe EOAs will be replaced with the default implementation. With a default EVM implementation, like a proxy pointing to a precompile, and this contract will be upgradable, so the user will be able to set implementation to replace it, for example, to a contract wallet that has a social recovery or a multisig. But before we can get to that point, we need to start experimenting. We need to start experimenting with the different models. So this proposal standardizes the way to send these user operations and leaves everything else to the contract. So the community can start experimenting.
Yeah, that's an interesting point because if a proposal is core, unless that is deployed on the mainnet, experimentation is limited.
Yes, and we also know that in the next couple of hard forks, we will not be able to add such changes. I mean, it's first we have the merge, and then we need to add the withdrawals, and there's going to be the vehicles, and there's so much going on that I think if we had to wait for a consensus change, then probably it's more than a year away.
That's right. We are having merge right now, so we really do not expect a lot of changes on execution or consensus level as such. It will have a long wait. So my next question is about the model that is chosen here. I understand there is a usage of a separate mempool. So can you talk a little bit about the advantage or limitation that you may have experienced with using this additional mempool here?
So we haven't really started experimenting with the mempool because there is no, there is no traffic yet, because it's just, it's currently only on testnet. But we have the restrictions that we talked about. We have the restrictions to protect the mempool, and so hopefully the experience will be similar to using the current mempool. I don't know, Kristof, do you have anything to add on the mempool?
I mean, I think the mempool, using a mempool means it's quite easy. That was what basically allowed us to make this an ERC instead of an EIP, right? That's what made it so that these user operations can sort of float one abstraction layer above transactions. So in that case, it was very useful to use it. But it did mean that it was quite tedious to apply all these opcode banning, all these DOS mitigation things that we've mentioned previously, that you have mentioned. So it's kind of a double-edged sword in that sense.
That makes sense. I mean, maybe when it is on mainnet, then the status will be more clearer if it was useful or not. All right, let's talk a little bit about wallet implementation. It's evident that this proposal is mainly useful for wallets and DeFi and similar projects. You did mention about like upgradeability, right? The old wallets can be upgraded. How about the multisig? Like, how do you think this proposal help deal with multisig signatures?
Yes, so as you saw, the wallet, the signature is just the entry point is agnostic to the signature type. It's actually just a bytes. It's just a bytes array that we pass to the validation function. So it is entirely up to the wallet, to the contract wallet, to decide what to do with the signature. It is given the request ID, which is the hash, which covers the hash of the entire user operation, the chain ID, and the entry point address. And then it's given the signature. Now, this signature could be, for example, a multisig. It could be multiple signatures or an aggregated signature or any such solution. And as long as the contract knows how to verify it, that's fine. So let's say you were using the default simple wallet, the one that just checks ECDSA signature, and then you want to switch to a multisig. Then all you need to do is to set the implementation of your wallet in place in the same address. You set the implementation to a new one where the validation function is a multisig that you manage in the wallet. You can implement, for example, you could replace it with a version of Gnosis Safe that knows how to that has a validation function for user operations, and then the validation is now the Gnosis Safe validation.
Cool. Being agnostic is helpful here because sometimes there can be delay in receiving signatures. So whenever it is ready, then that can be collected by the bundlers, I hope.
Yeah, the bundlers only get the user operation when it's ready, when it's already have a valid signature. So this needs to happen off chain, just like it does with the multi-sig implementations like Gnosis Safe. Someone needs to collect all the signatures and then submit a user operation that contains all of them.
That's nice. That's nice. All right. So in your presentation, there was something related to security and attack. I know there are already a lot of mitigation plans that are mentioned on the slides. I'm just wondering, like, how comfortable you guys are as a developer relying on this higher layer infrastructure and just have avoided the entire consensus layer protocol change over there.
Yeah, so here it's important to distinguish between risks to the wallet or paymasters and risk to the bundler. And we don't rely on higher level infrastructure for protecting the user, because this would make the bundlers a trusted party, and they are untrusted. They are essentially miners. So the security is enforced by the entry point contract, which makes sure that wallet operations only happen if they were properly authorized by the user and validated by the wallet. Now, if it's and if there's I would argue that a smart contract that enforces it is equivalent from security standpoint to a protocol level protection, but it also has an advantage over it, because if there is a bug, if we find that there's actually a problem, something that can be done to a wallet, we don't need to wait for the next hard fork in order to fix it. We could immediately deploy a new entry point, and wallets can start switching to it. This is of course an opt-in process. So all the wallets should have a set entry point function where they can change they can switch to a different entry point if they see fit. So the thing that is enforced by the higher level infrastructure is the protection against DOS, is protection for the bundlers. So and this doesn't need to be part of the protocol. They should protect themselves using these methods.
And when it comes to protecting them, the bundlers, we've basically, we believe we covered all our bases, right? But that's the cool thing about this, about having an ERC as opposed to a consensus changing EIP, that it'll be since there's a slow rollout, we'll be able to see and change things if needed. We don't think any changes will be needed to the mempool behavior, but it will be possible.
That's right. Having some change on ERC level is way easier than on a core EIP level. All right. And there was this one discussion about the replay attacks with respect to the chain ID field. I believe there was some concern raised by some of the user in Fellowship of Ethereum Magician page for discussion tooling. Could you talk a little bit about this replay attack?
Yes, of course. So we included the chain ID in the signed message. We included in the signed message to ensure that the user operation cannot be replayed on other chains. Maybe, I mean, if someone was looking at an earlier version of this ERC, in an earlier version, we actually forgot to write it in the ERC despite having it in the code from the start. So we added it later. Now the reason it is needed is that a replay on a different network could have unexpected effects. For example, let me give an example. Since the create opcode doesn't, when it creates a new contract, it only depends on the deployer address and the nonce, not on the code, unlike a create2. The same deployer could actually create different contracts at the same address of different chains, right? So let's suppose a user signs a trade to a new DEX. Let's call it a sashimi swap. And sashimi swap it's a great project. It's running on Ethereum, and the user uses it to sign a trade, trading ETH to DAI. And later, the same deployer, the sashimi swap deployer, uses the same deployment key to deploy a simple proxy contract at the same address that it used for the DEX on Ethereum. Now it does that on Polygon, and the user happens to also be holding assets on Polygon in the same in his address there. So now the deployer can replay the user operation on Polygon, which would transfer the user's matic, which is because it was transferring ETH on Ethereum. So it will now transfer the user's matic to the proxy, attempting to trade against this proxy. And of course, the proxy is not going to give any DAI, but it's going to keep the matic. So it's so to prevent such things, we absolutely must cover the chain ID.
Right, that makes a lot of sense. because this is like not for Ethereum, and this also allows to use any other token defining chain ID as a lag of value here. I have a question related to Paymaster. It seems to me like some of the use cases, those were proposed by EIP-4337, are already being provided with this proposal with the help of Paymaster. So do you think that 3074 will not be needed if we have this proposal on board?
I think 3074 made different trade-offs because it's an EIP. So it's it supports pretty much the same use cases. You could do everything that you can do with this. You can also do with EIP 3074 and vice versa. But the difference is that 3074. First of all, it requires requires consensus change, and then it also enshrines the EOA model, which we're trying to eventually move away from. So we're trying to create something that can be native, like natively use these contracts. Now it can. So like I said, you could write paymasters with 3074, but there would be some security risk involved, because when you sign an auth for an invoker, for a 3074 invoker, you have no way to ever revoke it. It's like you are adding modules to your wallet. And these modules, you keep collecting them, you can never uninstall them. And later, if a bug is found in any such paymaster, in any such invoker that is used as a paymaster, then it has a long-lasting effect. It's going to affect your wallet forever. So you need to switch to another address immediately. Whereas with 4337, the paymaster only affects you in the current user operation. It doesn't get any authorization to do anything on your behalf. It only pays for the gas. And if a bug is found in a paymaster, you can just stop using it. If a bug is found in the wallet code, you can just set a new implementation, and then the old code no longer has any access to your account. Whereas with 3074, you have no way to remove the access for the buggy code.
Also,
there are of course some pros to a 3074 which must be mentioned. First of all, it would be easier for users to start using immediately with their existing EOA. And second, there is less gas overhead. As Kristof mentioned, there is gas overhead. In entry point, which you wouldn't have to incur when using a 3074.
yeah, and I think it's also important to mention that there's also a sort of philosophical difference between 3074 and 4337. So the question we have to ask ourselves is, which type of wallet do you want to incentivize for Ethereum to use? Do you want to incentivize EOAs, or do you want to incentivize smart contract wallets? And we believe that for the most part, smart contract wallets are the future of Ethereum, and that's why we're trying to make an EIP which incentivizes that. But there technically wouldn't be any clash between these two EIPs. It would be completely feasible on a technical level to include them both on chain. Yeah.
That's a fair point. It's up to the community, like which one they want to use. And because 3074 is a core EIP, so if that is a change, then it has to be like implemented all across the network. But if people want to choose smart contract wallet over EOA, ERC will be available.
Yes, and if 3074 is accepted, then of course the entry point would be modified to use it. It will be or it will be much easier. It will be possible to make the current proposal cheaper to use.
All right. So, I mean, talking about this entry point and like this, there was this point in security consideration of JAS where it mentions that it relies on the state provided by EVM. I wonder, will there be any change expected with the introduction of merge?
No, the merge happened.
Yeah.
I
Sorry,
don't,
Kristof.
Yoav, correct me, but if I'm wrong, but I don't think so. The merge is a level on the consensus layer of Ethereum and doesn't impact the EVM state at all beyond the replacement of the difficulty opcode, which
That's
we have
right.
already banned. So since it's a banned opcode during validation, we don't expect any differences coming from the merge.
Right, that's correct. The merge should not affect the merge happening at the consensus level should not affect this because everything we do here is done at the execution level, and we don't use the difficulty, which is replaced with sort of random. So yeah, it's and of course the bundlers will then be block proposers, which will make this far more decentralized, I think, because now every block proposer can also become a bundler, and with the block, and there's the block proposer separation being considered, which will make it even easier.
Right. So it means like as we were thinking of having beneficial being the bundler here, it can be stakers who could act as bundler.
Yes.
All right. Yeah. All right. That's all on that part. I think I have one last set of questions related to EIP status. It seems like people have already started implementing. I know we just discussed about Nethermind implementation. I wonder, as co-authors, what do you think will be needed to move the proposal to the review status?
Yes. So the contracts. We only need one implementation of entry point, of course, because it's a singleton. So the OpenGSN team wrote the contracts, and they are being audited. They are being audited right now. So hopefully, in the next few weeks, after finishing the post-audit fixes, it's going to be deployed. It's going to be deployed on all the networks. And on the client side, Kristof can elaborate. But Nethermind Nethermind has been working on it not just for the Nethermind client, but also on Geth.
Right, we've developed client implementations for the CIP for both clients, and they are working quite stably. We have a separate DevNet just for ourselves, and we're also running the Nethermind client, which is a girly validator using this account, using this ERC's mempool as well.
Yeah, and also on the implementation of things on top of this ERC. First of all, you have so there's a samples directory in the contracts showing a few working paymasters and a wallet, and there are already wallets that build POCs on top of that. For example, at LISCON in Lisbon, Argent built a version that supports this ERC. So Argent wallet, for example, could use it.
Nice. So we already have a wallet implementation there.
As a POC, I don't think it's
okay.
I don't think it's a production, but they did demonstrate a working one already.
Yeah, of course, and it makes a lot of difference for these potential wallet users, whether this EIP is audited, right? So we expect that after the audit is complete, there's going to be a lot more willingness to make in the future production ready versions as well. Gnosis Safe also experimented with this EIP for example.
And one more important thing about this: once it is ready, it's also going to be deployed across different chains. So it's going to be deployed, for example, on rollups like it's going to be deployed on rollups like Optimism and Arbitrum, and it's going to be deployed on other layer ones that are EVM compatible. And this opens up interesting use cases, because combined with Paymasters, it allows users to perform cross-chain operations, to use bridges or to use decentralized exchanges that are working on that have liquidity on multiple chains, without even knowing about the other chain, because since the bridge can be wrapped with a Paymaster. The bridge can be wrapped with a Paymaster, which means that other assets can be used as part of the transaction to pay for operations on multiple chains. It makes it really easy once it's deployed on all of these chains. It makes it really easy to transact across chains without having to get the currency of each of them. So this can all happen fairly soon. Once we reach mainnet on Ethereum, it will immediately be available on mainnet of other networks as well.
Right. So I believe once this audit report is available, the proposal will, as a proposer, you guys will be in a comfortable stage to move this proposal to review and then to last call and eventually to the final status.
Yes. Now I don't really know the process of. Since it's an ERC and not an EIP, I don't know what it means. What the final call actually means. It can be used in its draft form as well. So how does the status affect it?
Right. ERC basically is a standard track EIP with ERC as a category. There are 4 standard track EIPs, and ERC is one of those. So it basically follows whatever is there for EIPs, except it does not need to be deployed in all the clients at the same time. It has to be on the project level, the application level, and it can be done independent of that. However, the process of a status change means similar thing like for core, networking, interface, and ERC. That means when a proposal is like in discussion or early stages, we can keep it in draft. When you think that it is ready for community review, more wider eyes should be looking into the proposal, then we move it to review. Then EIP editors consider it more serious. And once it is like in completely ready and you think that now we don't need to change any spec and everything is documented, well documented, we have all the references added, then you can push it to last call. Other than last call, there is no wait time. Last call generally has wait time of 14 days. It has to be there for 14 days. And unless it passes that time period, you cannot push it to final. But once that is over, it is on the author to push the proposal. Let's create a pull request to move it to the final status. So we are trying to move proposals to final status as much as possible. And we are discouraging people using it unless that is in the final status.
All right, thanks for explaining. That makes it much clearer for me.
Right. So yeah, at any point, if you need any help related to process or something, you are welcome to just tag any of the EIP editors, or you can reach cat headers. We are trying to work with authors and help them push the proposal to the final status.
All right, thank you.
All right, I think we are a little over the time. Anything else anyone would like to share with our viewers with respect to this proposal or in general?
No, everyone is welcome, and everyone who's interested in this proposal is welcome to join our Discord. We have discussions about this proposal and implementations. So we welcome everyone.
Absolutely.
Well, thank you so much. Generally speaking, account abstraction is a key concept in Ethereum, and there are multiple proposals suggesting how to make best use of data. I hope information shared today will help the community have a better understanding of account abstraction and also help move EIP-4337 to become a standard for better usage of that. That means projects and decentralized application implementing it in their own project. Thank you, Yoav and Kristof, for taking out time to provide an overview. Thanks to all our YouTube viewers for watching. Be sure to follow the discussion to link, provide feedback to the EIP. Check out the YouTube description links for all related links. We will try to add the Discord and other information. Those are shared in the slides in the description for you to be reaching out to. Should you have any question on this or any other proposal, let us know in the comments. Share it with Ethereum cat holders on the Discord channel. Subscribe to ECH YouTube channel if you haven't done it already. See you next week with 3 special guests and 2 special EVM proposals for Shanghai, EIP-3855 and EIP-3860. So stay tuned, keep watching, keep sharing.